Hello, I am Nabil Asar as the group representative. I have to explain the problem number 3.8. Let's take a look at this question first. The question here is saying that the 10 kg lamp is suspended from the three equal length cords. Determine its smallest vertical distance S, which is this, from the ceiling if the force developed in any cord cannot exceed 50 Newton. So basically, what we have to find is the vertical distance S. For better understanding, let's take this point as O. We can see the free body diagram that the tension force is 50 Newton maximum working in each cord. I mean, this cord is 50 Newton working here. All of them are 50. All of them are 50. This one is also 50. This one is also same. So in this particular problem, we only need the components of the tension forces which are acting in the z-axis only, in this axis only. We need to also calculate the gamma angle and the weight force of the lamp. So for calculating the weight force of the lamp, we need to multiply 9.81 with the weight of the lamp. So the answer is 98.1 Newton, which is actually acting downward in the z axis. So if I add the z axis, like all the axes is like this, is the z axis, is the y axis, and is the x axis. So weight is working in this downward z axis. Now by looking at the xz plane, I mean this plane, xz plane, so if I draw it here like this, is the x-axis, is the z-axis, and the tension force is working like this, creating an angle of gamma. So we can clearly see that the component of T cos gamma is working to the upward positive of z-axis. So this part is for only the z-axis, xz-axis. And now for this one, so for this part is working in the yz plane, y and z. So it's the y and it's the z, and the tension force is working like this, creating an angle of gamma. So again, the T cos gamma component, tension force component, which is T cos gamma, is again working in the positive z axis. So, and now for the last part, it's clearly indicating that it's created gamma, an angle of gamma. The tension force is working, is the z axis, and is the component of this tension is working again in the positive z axis. So by summing up all these forces, we can get to this equation. So here, one of the noticing factor is that the weight force is negative, because weight was acting in the negative z axis, which was downward. The negative z axis, is the positive z axis, is the y, and is the x. So here we can calculate gamma, and the value is 49.16. So now we need the value of s, the vertical distance that was needed, that was asked in the question mainly. So if we look up to the xz plane, again we have got the perpendicular distance 600 millimeter, and we just only need this distance, which is OD, the horizontal distance, in xz plane. So if I draw it again like this, xz plane, in xz plane only, tension force is working here is the O point, is the A. We have got the perpendicular distance, which is 600, and the horizontal distance and is the gamma angle. So if we apply trigonometry formula 10, we can get this we can get the value of S from this equation. So tan gamma is AD, perpendicular distance divided by horizontal distance in this case. So from that we get the value of S 519 millimeter. That's the actual answer. Thanks for listening to me. If I make any mistake, pardon me, doctor.